Welcome you all. Myself Rohini Bhadane. I'm today in session we are going to see what exactly the insertion sort is. In this insertion sort is very simple sorting algorithm that works similar to the way you sort playing cards in your hand. The array is virtually split into a sorted and an unsorted part. Values from unsorted part are picked and placed at the correct position in the sorted parts. That's why it is called as a insertion sort. We are directly inserting an element to a correct position. For implementing this sort, we are using the algorithm. By this algorithm, we are going to sort an array of size n in ascending order. First step is iterate from array position 1 to array of n over the array. Second step is compare the current key element to its predecessors, previous elements. Third step, if the key element is smaller than its predecessor, compare it to the elements before. Move the greater elements one position up to make space for the swapped element. So this is the algorithm. By using this algorithm, we are implementing this insertion sort. Now we will see one small example for this insertion sort. The very first we have taken one unsorted array having the elements 4, 3, 2, 10, 12, 1, 5, 6. Very first I am going to compare 4 and 3, the first two elements. 4 and 3, after comparing 4 and 3, we are getting that 3 is less than 4. So 3 is moved first and 4th is swapped at the location of 3. At next position we get the array as 3, 4, 2, 10, 12, 1, 5, 6. Now we are going to see the next element key point, that is 2. This 2 is going to compare with our first element, that is 3. Then we can find out that 2 is less than 3. So we are moving 2 in before 3 at the location of 3, and all other elements are swapped to the next location, and we are getting the elements as 2, 3, 4 as a sorted array and unsorted having 10, 12, 1, 5, 6. Now the next key element is our 10. We are going to compare this key element with 2, 3, 4. But we found that 10 is greater than 2, 3 and 4. So there is no need of swapping his here. After that, at next position, at next level, we found our key element as a 12. 12 is a key element. Now we are going to compare this 12 with 2, 3, 4 and 10. But we found that 12 is greater than all these 4 elements. So there is no need of swapping. Now the next element 1 is considered as our key element, and now we are going to compare this 1 with our elements. So we are going to first compare with 1 with 2. We found that 1 is less than 2, so 1 will be swapped at the position 2 and 2 will be swapped to the further location. So what we get, the array 1, 2, 3, 4, 10, 12, 5, 6. After that we getting the next key element is our 5. This 5 element we are going to compare with the all elements. So first we are going to compare 5 with 1, but it's not less than 1. Next with 2, next with 3, next with 4. But there is no need of swapping as 5 is greater than 1, 2, 3, 4. Now we are going to compare 5 with 10, but here we find out that 5 is less than 10, so there is a need of swapping the elements. So 5 will be moved at the location of 10 and 10, 12, 6 will be moved at the next location. So what we get, the array 1, 2, 3, 4, 5, 10, 12, 6. At next iteration we got our key point as a 6. This 6 is again compared with 1, 2, 3, 4, 5. But there is no need of swapping. So after that 6 is compared with 10, but it found that 10 is greater than 6. So there is a need of swapping. 6 is inserted at the location 10, and 10 and 12 are swapped to the next location. So like this, we are picking up a key point and putting this key point to the correct position. So that's why this kind of sorting is called as a insertion sort. And after following all the steps, we are getting our sorted array as 1 2 3 4 5 6 10 11 10 12. Now one more example I have taken here. In this example, I have taken just 5 elements: 12, 11, 13, 5, 6. Let us look for I equal to 1, second element of the array, to the fourth element, that is last element of the array. I equal to 1 since 11 is smaller than 12. So move 12 and insert 11 before 12. What we get? 11, 12, 13, 5, 6. Next, I equal to 2. 13 will remain at its same position as all the elements in A of 0 to 1 minus 1 are smaller than 13. So I am getting my array sorted as 11, 12, 13, 5, 6. Now I am going to increment my I equal to 3. So 5 will move to the beginning and all other elements from 11 to 13 will move one position ahead of their current position, and I get 5, 11, 12, 13, 6. Now I am going to increment I equal to 4. 6 will move to the position after 5 and elements from 11 to 13 will move one position ahead of the current position. So I'll get my sorted array as 5, 6, 11, 12 and 13. Now I am going to show you demonstration of this insertion sort using C. So here is my program for implementation for insertion sort. Here I am going to sort my elements in ascending order. Very first I have included stdio.h header file. Main method I have written here. Some variables I have declared here. CLR SCR for clearing the screen. Now I am going to accept number of elements that I want to sort, and now I am going to accept the numbers by using for loop in array C. Now after accepting the array, I am going to implement my insertion sort by this code. That is, I have taken for loop is here. The very first I have taken key position t equal to array of c, that is c equal to 1 first position. 0th position array will be started. 1 is my second element of array. So that will be my key point, key position that I am going to compare with all the elements. So here again I have taken one more for loop, and here I am going to check whether array of d is greater than t, that is the key position. If it is, then I am going to swap it, else I am going to break it. And if flag it is set, then I am going to set my next position equal to key position. So this is the simple logic behind my insertion sort. After following this, I am going to print here sorted list in ascending order. So here for printing that array, I am going to use again for loop here, and after that get ch and return of 0, as I am going to use here int main. Now I am going to compile the program. Alt F9, Control F9 also you may use. After compilation, I am going to run it. So this is the running of program. Enter number of elements. Suppose I am going to enter 7 elements here. So now I am going to enter all the elements here. Suppose 10, 90, 60, 30, 50, 20, 40. So these are my unsorted elements, and after implementing insertion sort, I am getting the sorted list in ascending order as 10, 20, 30, 40, 50, 60 and 90. So this is the way I can implement insertion sort using C. Thank you.